Okay, so I apologize for the delay in getting assignment 4 posted here. I've been pretty sick the past week, and you can probably still hear it in my voice. Um, so that's why I've had some delays in getting grades up for your assignments. I'll be looking at them this week as I have time catching up here. I'll also be posting the video for the coming week as soon as possible. I believe that the topic of that is array functions. I'll have to look back at the syllabus. But array functions are actually kind of probably the next place I'm going anyway, because I'm actually doing something at a coding camp up here in Orono for things that look like array functions anyway. So it's a good context. So what I'm going to do is use this video to kind of go through the idea of assignment 4 so you can have an understanding of what it is I'm asking you to do. So I'm going to walk through the assignment document here, which you can find on the folder, of course. So this is, of course, due on July 7th. I encourage you to have a good 4th of July weekend. And in the spirit of the 4th of July, and one of the things that is really important about our country is that we, in fact, have a democracy. The fact that we have a democracy allows us to vote for various aspects of our lives, such as who represents us in various positions in our country and different, let's see, referenda, stuff like that. Okay. So what we're going to do in this exercise, and again, I do this because I do research in this area, but I also believe in social literacy. We're going to look at the idea of how elections can be won or lost based on different areas. Okay, so I'm not going to subscribe this to any ideology or whatever. I would never do that. But the general idea here is my research focuses on um, the idea of what's called gerrymandering. So gerrymandering is this concept that goes back to 1812, which is a way that political parties typically will have influence in how the lines are drawn in a map, okay, to set up who you vote for the House of Representatives or the state House of Representatives, things like that, or state Senate districts, these sorts of things. U.S. Senate districts, president, those sorts of things are handled across the state, so there's really no impact of that. Now, I think also that that's not the case because if you think about if you've ever been in an area or been in a situation where um, the majority of people around you believe something that you don't, you're less likely to share your opinion because it almost seems like it's a useless concept. So at that point, it's hard to say that this is actually, the proper representation for an area, even if everything is logically taken care of by state rules. Okay, so part of my research involves simulating potential redistricting plans for the United States that have no hands in on the process, which means that the computer is given the rules of the state. For instance, that the thing has to be connected, so on and so forth. That doesn't matter here, and then the computer executes those rules, and then my job is to attach the idea of voting to it. So how would that theoretical district vote given what we know about it? The research in political science suggests that the best way to figure out how that district would vote, i.e. its partisanship, for instance, is to look at the presidential vote. And the reason for that is it's not typically moved by incumbency. So if you have a president in office, if you oppose the president's view, you're not likely to vote for them because they're the incumbent. Okay? They would have to have been extremely stellar for you to do that, or extremely centrist, or something like that. Um, and if you are likely to vote for them one time, you're likely to vote for them the other time, something like that. So that one tends to be fairly stable. in terms of if you're going to vote one way, you're not likely to change that based on who you have access to on the ticket necessarily, with the incumbent anyway. When you have an election such as the one we previously had, where you don't have an incumbent, you may see different behavior, but it shouldn't be that far different in terms of a person switching which side of the aisle they would vote for, or something like that. But to do this, one of the things that's important is to be able to say, well, how does a precinct vote, right? Because when you put a congressional district together, it's a group of precincts. So when I show you the Excel file that you're going to be working with, I'll show you kind of what the idea is there, and you'll see pretty clearly that precincts link to congressional districts, and we elect our representatives through those congressional districts. So what we're going to do here is try to figure out how current congressional district plans in 2000, okay, so the 2000 census occurred. So in 2002, the first election or in 2000, districts were drawn. In 2002 would be the first election those districts took force. But what we want to look at is the idea of how stable those districts are over time. So it's not enough to look at one election in a district. Let's look at several. Okay, so we're going to look at the last 5 presidential elections in the state of Colorado in this case. Colorado is a swing state. We're going to look at that and just see what might be out there. And it's not something I'm going to ask you questions about per se to make conclusions about it, but it's something that might be interesting for you to look at. And I don't even know what we would find in there, but that's one of the things that I'm researching at this point is the stability of these sort of districts and how they're drawn. Okay, because that's part of this puzzle of looking at, is there a bias put into this process? So what we're going to do is employ a philosophy of how to predict precinct votes, given that we know the precinct votes precisely for a single election. And in this case, some researchers at Harvard, Stanford, and Michigan actually collected all of the data for 2008 because 2008 was a landmark election historically because it produces the first black president. Okay. And they wanted to understand, well, how did Obama get elected? Okay. So using that data, we're going to use the philosophy called even swing, which is a fairly simple procedure, and use that to predict the votes the other years, given that we know the county votes themselves. So let me pull up a PowerPoint slide here so I can kind of get you the idea of what's going on. So I like to do this using examples that I know people should be aware of. So let's, and I'll do it by kind of making so this is our county, okay? So for instance, if you are local to Augusta, Kennebec County, something like that, we can assume this is Kennebec County. If you're local to Bangor, we could call this Penobscot County, whatever, right? So this is a county. So I'm going to put a label there just so we know what we're looking at. Okay, this is my county. Within that county, I have different, let me get something that can draw random looking polygons like that. Okay. We have a series of different shapes. Okay, and let me give that a fill. That. Okay, and then we have another shape. We'll do this. You'll see that it really doesn't matter how I do this. I can always overlay things Okay, and we can draw another one. Let's do that. We'll make that like that. Okay, and we'll make one more for good measure. Let me take this guy and pull it down a little bit. All right, and I'll shift that down like that. Okay, so what we have here is we have a county that has four different towns in it. Okay, so for instance, let's call this, I'm going to call this Stone County, for instance. And we have Quarryville here. And we have Rockland here. And we have Granite. I'm just moving these so we have access to them. I'll rotate that a little bit just so we can make sure everything looks okay. Size it down a bit. Do one of those numbers. There we go. All right. And then we can take this one, and this will be let me see. I got to make that text black. Gold. Okay. So we have 4 towns in Stone County. Okay. And they are Rockland, Granite, Gold, and Quarryville. Okay. So the purpose of what we're doing here is to look at what happens to the votes of these over time. Okay, so let's say we have a table. So let me insert a table that will have the town and its vote totals for a particular election. And we have 4 towns and we have a header. Okay, so let me pull this over here. And let me grab all these guys and pull them over there. Okay, so we have the town, we have the Dem vote, and we have the Rep vote. Okay, so in this case we have Granite, we have Gold, and we have Rockland, and we have Quarryville. Okay, let me extend this a little bit. All right. So let's say that Granite is the population center of this county, and it has 10,000 Democratic votes, and it has, say, 5,000 Republican votes. We have Gold, which has 200 Democratic votes and 3,000 Republican votes. We have Rockland, which has 500 Democratic votes and has 1,000 Republican votes. And then we have Quarryville, which has, let me see here, 300 Democratic votes. And then over here, Quarryville has 2,001, let's say, Republican votes. Okay? So if you add these up real quickly, you'll see that there are 11,000 Democratic votes and 11,001 Republican votes. So if this county were a district, the Republican candidate would win, okay? Just by what we see in a particular year, Okay, so this is a particular year. Now, we could re-envision this table in a different way. So let me, and again, this table is about a county. So I just made a copy of the table. We can think about this a different way. We can think about this as the Democratic vote is 66.7%. Wait, actually, no, not that. So there are a total of 11,000 votes. 10,000 of them in this county came from this particular city. So this is 10 divided by 11. Okay. This would be 5,000 divided by 11,001. Okay. And you get the idea here. So this will be 200 divided by 11,000. This will be 500 divided by 11,000. This will be 300 divided by 11,000. I'll put the zeros on this just so we're consistent. And then we'll continue to extend the table so that we can see out the whole thing here. Okay, we have that, and then we have that, and then we have that. Okay, these of course are percentages. All right, because they're percentages, we can look at them in the future. Okay, we can apply these percentages to a different set of county total votes. Okay, so every year, essentially on election night, the county vote totals are collected. When you watch CNN or something like that on election night, you'll see that the map is colored based on how intense the county supports a particular candidate. That's how. Okay, so what we're doing is we're taking county totals for the last 5 elections, and we're using the precinct totals in 2008 to figure out what the precinct totals were in 2000, 2004, 2012, and 2016. Now, of course, that's not completely accurate, right? However, it's a very good starting point. Okay, so that's the general gist of this, is what we're doing. This philosophy is called even swing. Okay, so it says that in a local area, such as a county, okay, if I know the percentage of how the distribution is within that county, I can apply that distribution in subsequent elections just by changing the vote totals of the aggregate and applying the percentages back. That's what we're doing here. So, even swing is the idea that if a candidate garners support or dissension from a voter base, that support will be consistent over a county. Okay, so I just showed you what I mean by that. So the practical implication of that is, let's say that there were 20,000 voters in Kennebec County in 2008, 10,000 of which for Obama, 10,000 of which for McCain. Let's then further assume that the city of Augusta provided 6,000 total votes, 3,000 of which Democrat, 3,000 of which Republican. In other words, Augusta was just like the county itself. Okay, now again, these are just numbers I'm making up. Now, let's say in 2012 that 9,000 people in Kennebec County voted for Obama and 12,000 voted for Mitt Romney. Okay, so the baseline has now changed. What even swing says is that 30% of 9,000 voted for Barack Obama in Augusta. Okay, so in this case that's 2,700. And then 30% of 12,000 voted for Mitt Romney. In this case that's 3,600. The reason for that is Augusta in 2008 accounted for 30% of both of their vote shares for that county. That's the idea. So the task that you're going to do, I provided you with the following information, and I'll show that to you in the Excel sheet. So you have each precinct in the state of Colorado, which can be found, let me maximize this, which can be found in the voting district tab right here. This is the name of it. Okay. You have the county that the precinct is part of. So if we go back there, there's the county. Okay. If we go back here, the congressional district that the precinct belongs to in 2000 and 2010. Okay, so these are two different numbers. Okay. So here, and here. Okay. There are a total of 7 congressional districts in the state of Colorado. That's important. And then we have, let me see here, the voting totals for 2000, 2004, 2012, and 2016 for the counties in the state of Colorado for the Democratic candidate and the Republican candidate. So if we go look at the sheet again, if we go to county voting data, you'll see 2000, 2004, 2008, 2012, 2016. You'll see that 2008 is blank. You're going to be calculating that because we have the numbers for that for you to work with. With these, the Republican candidate is listed first, just to be consistent. Okay. Here is the state. You don't need that. They're all in Colorado. Here's the county name. So conceivably, you're going to use this information to help you. And this goes all the way down to Yuma. Okay. This column will help you select things from this column that, well, from these columns here, okay, that fit this bill of the county. Okay, so you can think about how you need to do that. Okay. And you'll see very clearly that this is a task that's rooted in what we talked about in recent videos about VLOOKUP and things like that. All right. So the information you have is enough to produce precinct vote totals under the philosophy of even swing using 2000 election as the base. I would like you to then compute the percentage of Republican votes in each congressional district for each of the 5 elections. Okay. To accomplish this task, you'll need to do a few things. What I will note is that not all the information for the function is given, just that you will need a particular function or functions in that process. So the first task you'll need to do is you'll need to calculate the total vote in 2008. So if you look at your sheet, here you have the blank things. You notice I got a little comment there. This is where question 1 will be. So you'll have to do it for McCain and for Obama and then conceivably fill it down. Then we have number 2. Calculate the percentage that each individual precinct's vote total for each candidate represents within its county. So in this case, we're only dealing with 2008. Okay? You will need VLOOKUP to do this so that you can look up the values you just calculated in step 1. For instance, if Augusta provides 10% of Kennebec County's vote for John McCain, the answer to this for Augusta's precinct should be 10%. Okay? Number 3. And if we go to the sheet, you'll see on the voting district, there's that group right there. Okay. Now, number 3, apply those percentages to each candidate's vote total in the data set to arrive at the projected vote total for the candidates in the other election years. Round this vote total to the nearest vote. You'll again need VLOOKUP, but you'll also need round to make that work. This is somehow related to the interest calculation in assignment 3, where you have to go chase some information from somewhere else. Following that example, if there were 5,700 voters in Kennebec County for Mitt Romney in 2012, then Augusta would register 570 votes for Mitt Romney. Okay, because John McCain was the Republican candidate in 2008, Mitt Romney was the Republican candidate in 2012. Number 4, calculate either the Republican voter share or the Democratic voter share in the congressional districts for both 2000 and 2010 for each election year if you play that election forward or backward. You can choose which, as I will not enforce an ideological preference here. You'll need SUMIF for that. This will be a series of percentages when you're done. Be sure to adjust the column label so that I know which it is. So if you choose to get the Republican share, please tell me that. If you choose to get the Democratic share, please tell me that too. Whichever of those you choose, as in assignment 1, make a 3-color gradient that will indicate the degree to which a district favors a candidate using conditional formatting. Remember, blue equals Democrat, red equals Republican. Okay? So one thing that I will note here, when I did make this file, I did the percentages here as if it were one congressional district set. You'll need to copy this set of columns here, S to W, and put them here in X to AB so that you have a 2000 redistricting plan here in this group and a 2010 redistricting plan in this group. Okay? So the point of this is so that we can use VLOOKUP for a purpose that it can serve. All right. This also gets us experience with the conditional functions and these sorts of things. So I, for one, think this is a really interesting exercise, and I just mentioned it at the coding camp that I'm working with, and one of the instructors there said that's a fantastic exercise and it's something that's really exciting and it's kind of interesting to look at, right? So this is one of those things that can be really, really beneficial to you. Um, Again, this is just data. It's not something that I would take a huge investment in from my perspective. This is just, I think it's a good part of social literacy so we can kind of understand how dynamics in the country change a little bit. All right. And it's a good data set. It really is. So that's what I really want you to get out of this. So when we do the array calculation things, I'll show you something that is used in more biology type areas, but it's also used in sociology to some extent as well. It will be somewhat related. It's the idea of how people move in the United States. I think that's a fascinating thing, so we can see how that drastically impacts different things around the country. That's where we're going to go next. That's what I'll show you, at least as an assignment, or not as an assignment, but I'll show you that as part of the video when we do arrays. So if you have any questions about this assignment, please let me know. Along those lines, also, if you are really interested in this assignment and what I'm doing here, I have opportunities for students to be able to kind of work with this sort of stuff. So one of the things that happens in the University of Maine system is there are, I believe, what are called Maine policy scholars. These are things that could make for interesting research projects toward that objective. And if you are interested in the types of data you're seeing here, maybe something that we could conceive of an opportunity to have you become a Maine policy scholar for different things. So have a productive week. Again, I apologize for this being delayed. That has to do with my health predominantly. So with that, have a good week.